Welcome to our virtual meetup. Today's topic is going to be the future of AI, a very fascinating topic. I'm going to cover logistics first and then introduce our very special speaker today. So in terms of logistics, those of you who are regular know this already. Essentially, David is going to walk us through his presentation. And if you have questions during the presentation, please use the Q&A button to ask those. And we'll make sure to get to those questions at the end. If you have a really detailed question, I'll also promote you as a panelist, and then you can go ahead and ask it live. So with that, it is my honor to introduce today's speaker, David Wood. David Wood was a pioneer of the smartphone industry, including co-founding Symbian in 1998. Symbian was a mobile operating system. I did my homework, I looked that up. So what an amazing accomplishment back in 1998. David's focus is on potential radical transformations in society and humanity. Transformations enabled by accelerating technological disruption and mediated by social and political reaction. David is the author or lead editor of 9 books. And what I'm going to do is I'm going to put that on chat, the link to David's books, if you're interested. In 2009, he was included in T3's list of 100 most influential people in technology. Alongside his paid consulting activities, David is chair of London Futurists, a non-profit meetup organization with over 8,000 members. That's a pretty significant accomplishment as well. That's a very good group of people, especially involved with technology and non-profit. David has an MA in mathematics from Cambridge University and an honorary doctorate in science from the University of Westminster. With all this experience and background, we believe that David is well positioned, well qualified to talk to us about the future of AI today. So take it away, David. Thank you for joining us.
Thank you so much, Pramod, for that great introduction. Indeed, I want to talk about the future of AI. And in fact, I'm going to talk about the ways in which artificial intelligence in 5 to 10 years' time, so relatively soon, might be very different from today's. In fact, I'm going to look at 12 ways in which it could be not just an extension of today's AI, but in various ways, not at all what people are tending to expect. I'm going to draw on my experience from more than 200 public events with London Futurists since February 2008, when we have often talked about possible futures of AI. I'm also going to bring some insights from my professional experience, both as a software architect and as a futurist consultant. And what I do in that role as a futurist is I make the case that it is useful and helpful, important and also possible to split our focus in life across 3 perspectives at the same time. We have to look at the present. We have to be good at keeping the balls in the air, delivering on the commitments we have made to partners and customers and investors, practicing, prioritizing operational excellence. But at the same time, some management focus, whether in our groups or businesses, or also managing ourselves as individuals, should go to finding incremental improvements on what we are currently doing, looking to a future that is in a sense more of the same. New clients for our existing products and services, or ways to enhance our products and services to make them cheaper or with more bells and whistles. And most good companies, most good organizations do the first 2 tasks pretty well. Where many great companies fail is in this third, spotting something that was not expected. This is the game change future, sometimes called disruptive change. It's when you aren't looking for something that is there, an elephant in the room, or here an elephant on the footpath, which if you don't notice it, could charge at you and kill you, destroy your business, throw your own plans into complete disarray. But if you do spot it early enough, you can learn how to take advantage of it and ride it to greater progress than ever before. So as a futurist, I help people to spot the elephants, to see the disruptions coming and manage the response to these disruptions. And it's not just by looking more carefully, it's by looking in different ways. It's by having different conceptual filters. An example from my own past life, 25 years ago, my business card did not say futurist, it said software architect or perhaps software director. And I was engaged with my colleagues in Scion, the pioneering manufacturer of handheld computers based in London. We had, in the first dimension, the focus on the here and now. We were incrementally improving our first million-selling handheld computer, which you can see there on the left from 1993. Then we were doing a significant step up, more of the same. We were designing a device that came out first in 1997 and this version in 1999, which had a better screen, much better apps. It was a 32-bit operating system, whereas the previous one had been 16 bits. It had touch sensitivity, and so on. But at the same time, we managed to realize there was a big elephant coming our way, which would mean that people would no longer be interested in these handheld computers. And eventually, we drew this picture envisioning the next 10 years or so of progress from about 1998. The trend that we were tracking ourselves in the parent company Scion was one of computers becoming more mobile, but we realized that another huge force, the elephant of the mobile computing industry, was going to disrupt our world with their phones becoming more intelligent, more smart. So we said we have to adjust our business plans. We created a spin-off company called Symbian that attracted investment valuing us at £100 million initially, with investment from the big three phone companies of the time that some of you might remember, Nokia, Ericsson, and Motorola. And patiently, we adapted our platform to make it suitable for what would become the world's first successful smartphones. And eventually, after long delays, we did manage to sell our software as the operating system in 500 million smartphones. There were successes and there were failures. I've just time to give you 4 quick highlights about disruption. Highlights which I believe are going to apply to AI in the future too. Disruption often goes through a slow, disappointing phase in which everybody says, oh, not that hype again, before it goes through the fast and furious phase in which everybody says, why did no one tell us this was coming? It's the kind of exponential takeoff. There's also the fact that disruption is only successful when there's not just new technology, but also a whole ecosystem of partners, suppliers, application developers with their own positive feedback cycle. And I'm going to say more about positive feedback cycles. Disruption, by the way, comes in waves, and too many people are focusing just on the current wave or maybe the next wave without seeing an even bigger wave coming, which is what I believe is the case for artificial intelligence. And each new wave brings its own new ideas and is typically led in part by new people. And finally, there's nothing inevitable about any of these disruptions. The technology makes them possible, but the actual outcome depends on human responses. And indeed, the future of AI is enabled by new technology, but it will be determined by what we humans manage to foresee and manage to do. So now let me look ahead. Well, actually, I'm going to look ahead by briefly, again, looking backwards. My exercise in looking ahead 5 or 10 years from today could have been applied in 2010, and if it was done in 2010, most of the predictions would have been wrong. Why? Because in 2010, most of AI was dominated by what we now call classical AI expert systems, which were incredibly successful in their own ways. They depended upon rules being captured by software engineers after talking with human domain experts. And there was lots of interesting progress to get excited about, not just logical calculations, but probabilistic reasoning. And there was some interest in machine learning and some interest in neural networks. But most people were pretty skeptical that neural networks could ever amount to much. Why? For empirical reasons, because neural networks only seem to work in a small number of domains. And there was also theoretical reasons. Some of the pioneers of artificial intelligence, some of my childhood heroes, in fact, Marvin Minsky, Seymour Papert, had apparently demonstrated theoretically in a book as long ago as 1969 that neural networks or perceptrons could not do much. So that was the past, but by 2015 to today, we look back at classical AI and we say, oh, that was good old-fashioned AI. We are now moving much further forward with deep neural networks. Machine learning is now very successful, in which the parameters are automatically trained. Of course, humans have to set the hyperparameters and set the design, but much of the logic is sort of inferred by the machines themselves. And after lots of slow disappointment up to about the year 2012, there has then been this breakthroughs, this unexpectedly swift progress in image recognition, language translation, speech recognition, and all kinds of other fields. Enabled, we now see, by a number of breakthroughs, the fact that there was large amounts of big data labeled, such as the ImageNet database created by Fei-Fei Li of Stanford, amongst others. There were improvements in hardware, GPUs and later TPUs that were very good at parallel processing. They were not designed initially for deep learning, but it turns out that GPUs are excellent in accelerating training. And then there was improvements in algorithms, such as slightly different ways of doing the back propagation, slightly different ways of doing the calculations, and numerous innovations in design as to which kinds of convolutional layers in the deep networks. Could the same happen again? Could our excitement about what deep learning networks do now, could that be overtaken by new breakthroughs in the next 5 to 10 years? I'm going to argue that is quite likely. I'm going to argue that we will quite probably look back at today's systems rather fondly, and we'll smile and say, oh, good old-fashioned neural networks. And what we'll have in the future isn't just better neural networks, and by the way, better classical AI in some kind of combination, but new developments. And to get this kind of disruptive change, there needs to be a supply of ideas, a supply of people working on it, and a supply of funding. I'm going to argue that there are plenty of ideas which look promising, and there are plenty of people poised to work on these breakthroughs, and there is certainly lots of money available. There is no shortage because of the demand for improvements in AI. There are so many companies in so many industries who see the possibilities to extend their profits in, for example, algorithmic stock trading, healthcare, medicine, gaming, entertainment, engineering, science, creativity, and so forth. In industry after industry, there is huge pressure to invest in possible disruptive breakthroughs, looking at some of the ideas which I'm going to describe shortly. And there's not just a commercial competition driving this forwards. There is a geopolitical competition. Indeed, we can say, not putting too fine a point on it, that the control of the world is at stake. And some people are waking up and realizing it, and others are sort of sleepwalking forwards. This you may recognize is the Chinese Premier, Xi Jinping, who is giving a talk filmed here on New Year's Day, 2018, shortly after China had declared its policy of becoming the world's leading AI power by 2030. And that, in turn, was shortly after China's best human player of the game of Go had been comprehensively beaten unexpectedly by software, Western software from Google's DeepMind group. And the Chinese, who loved the game of Go, thought that was unacceptable, and they've decided to invest substantially. And the reason I'm showing this picture is I'm told if you zoom in on his bookshelves, which some China watchers do, you will find books such as The Master Algorithm by University of Washington computer science professor Pedro Domingos. You will find Augmented Life in the Smart Lane by New York futurist Brett King. I just want to point out that the Chinese leadership are pretty sympathetic to engineering considerations, and they are getting this. So there is a strong political competitive pressure to invest more in discovering the new breakthroughs. And there are plenty of people who are willing and able to work on this. We have more people in the world than ever before, but that's not just more mouths to feed. It's more people with brains and innovation. People, by the way, who are educated around the world to higher levels than ever before, who are networked, using Zoom, using other networks more than before, so that ideas can bounce around the world, which leads more people to develop more tools and more technology. And by the way, with better technology, there are better networks and better education. So this feedback cycle grows, which is why we have more scientists, engineers, and entrepreneurs knowledgeable and acting and making a difference in the world than never before. We have more people who understand the principles of design, more educators. That's why we have more artificial intelligence being created, deep learning, driving progress in all these other fields, which is why there's likely more elephants of disruption ahead. Just one more word about these positive feedback cycles. I said if you want to spot the elephants, you need to have different kind of conceptual models in your mind. It is useful to see what's caused progress in the past. The biggest change in history probably came from the series of industrial revolutions. The first industrial revolution was when steam-powered machinery was developed, and it was developed by tools, crude, simple tools at first, but better machinery led to better tools, which led to better machinery, which led to better tools. The second phase of the Industrial Revolution from around 1880, according to various historians, included growth in synthetic chemicals, which needed to be built from chemical reagents, but the more synthetic chemicals there were, the more chemical reagents there were. The third Industrial Revolution involved computers gradually and then increasingly displacing humans from the workforce. Computers were difficult to build at first, but guess what? There is the field of computer-aided design, another field of computer-aided manufacture. So one generation of computers helps to design and manufacture better generations of computers, another positive feedback cycle. And then with software. Software is built, of course, by software engineers, humans, but using software to help them. Tools like debuggers, compilers, profilers, analyzers, optimizers, which is why smaller groups of software engineers are now capable of building higher quality software than ever before. That's the past. The future will have AI built not just by human AI engineers, but increasingly by AI tools. This is what I'm going to zero in on in the next few minutes. So I hope I've made the case that there is plenty of supply of finance available, plenty of humans available to work on this. What I haven't spelt out yet, and which I'm going to do for the next 5 minutes or so, is look at some of these ideas. In fact, 12 ideas about why AI with these pressures could be quite different pretty soon. And the first is even bigger data. Problem with our current data sets is they don't cover all areas of learning with sufficient annotation, well, we can now use one set of AIs to generate synthetic data and label it, which can then be passed to smarter AIs to learn from. It's early days, but remarkable things are being done. Also, we have one AI being used to clean up the raw data before being passed to another AI. So larger sets of AI coming as a result. Is this just a quantitative change? I think it may well be a qualitative change as well. So bigger sets of data. But of course, where most people want to get to is the other direction. It's learning from smaller sets of data, not big data, but small data. After all, that's what young children can learn from. A young child does not need to be shown a million pictures of cats and a million pictures of dogs to be able to distinguish them. Somehow there's already enough learning in their brain from evolution, which they can then adapt into new contexts to learn much more quickly. So this field of transfer learning and related unsupervised learning is potentially enormous once we can get it working. Somehow related is the idea that we can have self-learning systems that could teach themselves more by reading all the text in multiple databases, multiple books around the world. If you can put in a sufficient seed of knowledge and understanding, that knowledge could grow quite quickly. Now, in the past, whenever this has been tried, it's become unstable. The systems have made false assumptions and they have generated nonsense alongside lots of genuine insight. Well, perhaps it's now changing. GPT-3 from OpenAI in some ways is surprising people by what it can do. Of course, it doesn't really understand yet, but in the future, maybe GPT-4 or 5 could go much faster. And we could have an unexpected iterative growth of common sense knowledge. The fourth thing I want to look at is something that has become very successful in the last few years. Jan LeCun, one of the pioneers of deep learning, now head high up in AI in Facebook, has described this field as one of the most significant in the last 10 years. It's when you use two different deep networks in some kind of competition with each other, an adversarial relationship. One of them is trying to generate fakes of a sort. The other is trying to discriminate the real ones from the fakes. And surprisingly creative results are being achieved all the time. That's one way in which software engineers are copying an idea from evolution. Evolution has made lots of steps forwards, remarkably, by arms races of one sort or another, predators versus prey. Well, the field of computer science has had for decades other people trying to copy evolutionary ideas such as genetic algorithms. They have not yet been particularly successful or impactful in a commercial sense, but I remind you, neural networks were around for many decades before they broke through and were very successful. So that's one way in which we might learn from biology. Another way is when we learn from the biology of the brain. It's no surprise that many of the world's largest AI and IT companies have many PhDs from the field of neuroscience. And some of them are trying to copy things from the software of the brain. I can point to what Jeff Hinton is trying to do with his various formulations of capsules, only loosely inspired by what may be happening in the brain. Other people are looking more closely. There may be improvements in our software from that. There may be improvements in our hardware design as we copy some of the remarkably power efficient features of the brain's hardware that could come about. And sometimes that's called neuromorphic hardware. Another kind of hardware breakthrough could come from breakthroughs in quantum computing. This is particularly hard to forecast with any confidence, but I will say that people have already developed algorithms which could run faster and faster on quantum computers than on any other kind of processing. And there might be brand new AI algorithms which are enabled once people understand quantum computing more. That might break through. It's probably a bit of a low probability, but I don't want to rule it out. Then there are people who are copying another aspect of human biology, that's our emotional intelligence. The field of affective computing has made lots of breakthroughs in which software is taught to understand human emotions by seeing images of emotions on our face, including micro expressions. This software is able also to simulate emotions, and it's able to manipulate human emotions, sometimes for good, sometimes worryingly. Other people are working on a smaller field. More radically, they are trying to understand consciousness and put consciousness into their AIs. This would not be artificial emotional intelligence. In a sense, it would be real emotional intelligence. The last two of the 12 I'll just run through quickly. There is the proposal by pioneering computer scientist Judea Pearl that the big breakthrough will come when AI understands not just patterns of correlation, but the possibility of causation, realizing that when there is correlation, at least sometimes there is causation. That might be the breakthrough. And finally, there is the idea that greater intelligence will emerge out of networks, decentralized networks, in which simpler components combine to create higher powers. That's probably what's happening in our human brain. There is no single master module in our brain, but our processing power arises, it seems, from this emergent network. And I point to Singularity Net from Ben Goertzel as being the company that is making the best progress there. So 12 possible breakthroughs. How big an impact could these have? What kind of timescales are we talking about? I have to say, nobody can say for sure, because we don't know what's involved in making these breakthroughs a reality, and we don't know what will be unlocked as a result of these breakthroughs. It could be something small, it could be something larger. My advice is keep an open mind and beware of any dogmatic skeptics, including some AI professors who are, in my view, foolishly dogmatic in waving their hands and saying that none of this can make a big difference for hundreds of years, that there can be no artificial general intelligence for the foreseeable future. That is a dangerously complacent attitude. Bear in mind that experts, like other people, can indeed become trapped into their own paradigm of thinking. Great businesses fail because their leaders only see things as in the past. And I pointed out that pioneers of artificial intelligence, such as Marvin Minsky and Seymour Papert, failed to appreciate the ways in which neural networks might be different in the future. A single breakthrough from this list might open up many new insights, just as, if we go back, way back in history, calculus opened up an understanding of huge numbers of different fields of science. Quantum mechanics, with the breakthroughs of Schrödinger and Dirac and Heisenberg, 25, 26, 27, allowed many other physicists to make remarkable breakthroughs in short periods of time. Of course, there were the neural network breakthroughs in 2012 that caused large changes. So I am arguing that we should prepare now for potential breakthroughs and potential bad consequences. We do need to consider how this new breakthroughs could be steered or governed. We need to ensure that there is sufficient research into the potential issues arising. We should not follow the advice of Mark Zuckerberg of Facebook, whose motto for many years was simply move fast and break things. The consequences of moving too fast with AI without thinking of safety could truly be catastrophic. For 5 reasons, we could have the software that is very capable most of the time, but which harbors deep bugs inside its complex interlinking, especially if much of that software is opaque. Secondly, even if the software has no bugs, it could be that the specification we have given it is actually in some ways incomplete, and that when two AIs interact in various unexpected ways, there could be very bad consequences. We could talk about ways in which novel emergent capabilities might arise, just as we humans diverged from our evolutionary programming in many ways to care about more things than just the propagation of our individual gene lines. There is the risk that some of this very complex software could be hacked or misled by an adversarial attack, and the opposite problem, which is we may no longer be able to hack it, which means we humans who are supervising it or trying to observe it will lose the ability to turn it off if it starts behaving badly. And bear in mind that people using this software may have very different motivations. There could be military people who are in a hurry to get advantage of AI before their competitors and cut corners. This software can be used for big brother surveillance by capitalists who are pursuing profit, profit, profit. And they may say that profit is always for the social good, but we know that sometimes that's not true. We can be afraid of this software being exploited by financial hackers, political hackers, or even fundamentalists of various sorts. Religious fundamentalists or secular fundamentalists who have various suicidal tendencies or who hate humanity in some way or another. So this software, which could be more powerful more quickly than we expect, could have very bad consequences. It could also have very good consequences. I've written about these in some of my books. Potential sustainable superabundance is within our grasp, including use of this AI to abolish aging, to transcend the naive and dangerous ways in which we're currently doing politics, and to lead us on a roadmap to flourishing transcendence by 2035. If we want to dig in more, I could talk about practical advice in terms of how we should be steering the software, but I think it's time for me to pause and open up for questions. I hope that was interesting, and I hope that's given you some thoughts about not just today's artificial intelligence, but what might happen quite soon for good and potentially for ill too. Thank you.
Thank you, David. We have a couple of questions here from attendees. Again, if you have a question, please go ahead and use the Q&A button, or you can ask me to unmute you and you can ask your question directly. So before we go into Q&A, David, I do want to mention that zooming in on the bookshelf, that made me laugh really hard. So I needed that. Thank you very much for that good laugh. Okay, so the first question is from Guanan, and this question is very relevant if you have been following the news, which I'm sure you are, from the United States. He's asking about antitrust movements against tech leaders such as Google, Apple, Amazon, and Facebook. And his question is that going to hurt or benefit the development of AI, in your opinion?
This is a very important topic, and regulating big tech is not easy. It's very easy for politicians to make a mess of interfering in big tech, especially if the politicians fail to understand it. But we can't just let big tech do whatever they like, because although the leaders of these big tech companies are by and large humanitarians, they genuinely want to see a better world. They are also driven by their own engines of profitability, and there are some worrying signs as to what these big tech companies have done. I can point to the book Zucked. That's Zucked, spelt with a Z, by Roger McNamee, one of the early investors in Facebook, who became increasingly alarmed that both Mark Zuckerberg and Sheryl Sandberg, despite their many great qualities, were actually being driven by profitability far too much and were accepting dangerous things. There's many other books which I could point to. The Shoshana Zuboff's very interesting book on surveillance capitalism, and there's a book called Do No Evil, Scored Out, by the journalist Rana Farofar. I may have got some of the names wrong. So they all make good cases that we do need as a society to get involved in constraining what these big tech companies are doing. But we're going to have to do it very intelligently. We should not do it in a foolish or naive way, but nor should we just let it go. I would say that the most important invention of the last 100 years, in some counts, is a social invention called the mixed market. The mixed market means we allow the free market to do wonderful things most of the time, but occasionally we intervene. There are the fingers of the invisible hand and the thumb of the government, which intervenes from time to time when there are potential market failures, such as the growth of cartels or monopolies, such as lack of attention to externalities, such as fundamental asymmetries of knowledge. Economists know these market failures well, and it is the role of government, which has done well in the past. It broke up a big steel, it broke up a big oil, and it has done some important work in the past to ensure regulations. But it's done badly, it will work out wrong. So I'm not particularly a fan of big government or big regulations or heavyweight regulations. I am instead a fan of something that many software engineers will recognize, which is you need very focused processes in key areas. So maybe you don't need to dictate exactly how people should lay out their code, but you do mandate that all code should be logged into a software configuration management system. You do mandate that all code should have test code written for it and should pass. You do mandate that most of the code, if not all of the code, should pass code reviews before being accepted. So there are a small number of principles, and it will be the same, I believe, with the principles that govern big tech. And we must push for the kinds of things on my very last slide, which is a focus on transparency, a focus on highlighting biases in the data, a focus on explainable AIs, and we should not let the big tech CEOs away with saying, oh, we can't do this. Yes, they can do it, and we should put pressure on it. And we have to do it worldwide, by the way. The big tech companies will say, well, they don't want to be constrained with their hands behind their back because the Chinese companies and the Russian companies and other overseas companies won't have the same constraints. Well, actually, we need the whole world to sign up to these constraints. And I think there is some grounds for imagining we can do that if we have a sufficiently intelligent conversation with the political leaders around the world who do understand this, which sadly isn't many of today's Western political leaders, but some are. Some are inspired and can have that discussion with the Chinese leadership and others.
Yeah, great insights there, David. I think it almost sounds like some kind of a nuclear treaty or agreement among countries. Yeah, it cannot be limited to just one country. And when you're talking about explainable AI, I was thinking about one of the things that I'm very passionate about, which is bias in AI. In fact, you can argue that inherently there may be bias in AI because there's probably bias in historical data. A simple example would be somebody applying for a mortgage, and an AI system can deny that. But if it's an AI system making the decision, it's really hard to pinpoint what exactly was used to make the decision. So I think explainable AI, transparency, very important. Thank you, David. We do have a couple more questions here from the audience. From Subir, his question is, will AI lead winners take all in industry after industry? Won't it lead to greater disparity in the world?
If we do nothing, yes, that is what's going to happen. There is the tendencies to have more and more powerful companies succeeding with smaller number of employees because they're able to take advantage of the technology platforms. So this winner-takes-all scenario has been mapped out by MIT economists Andrew McAfee and Eric Brynjolfsson in a number of books they have written, such as The Second Machine Age, and more recently, I think it's called Machine Platform Crowd. I can't remember the exact title, but they have documented reasons why the successful companies of today, the ones who are in the first place, are taking more and more and more a share of the profits. If we compare the most successful companies in Silicon Valley today with, say, the most successful companies in Detroit, going back 20 years or so, Ford, Chrysler, and GM, in some ways, the revenues of these two sets of three companies, the motor companies in 25 years ago and the Silicon Valley companies today, in some ways, if you adjust for inflation, the revenues are similar, but the number of employees in the Silicon Valley companies is a tenth as many as in these motor car companies. And the stock market valuation of these companies is something like 30 or even 50 times higher. And this shows the expectation of what's going to happen in the future. So should we just accept this growing inequality? No, it's incredibly dangerous if we don't intervene, which is why we need political intervention, which is the point I was making in my last answer. We do need political intervention to ensure that the fruits of technological abundance are shared somehow to a degree to everybody, so that everybody in society is not as rich as everybody else. I'm not asking for that kind of equality, but that everybody in life has the means to live a good basic quality of life, partly implemented perhaps by a universal basic income, such as was advocated by Andrew Yang. But more important, actually, even than the basic income, is for society to set the goals to make the basics of a good life, including education, including healthcare, including nutritious food and accommodation, and including consumer goods. All of that should be brought to as low a price as possible, which means we should no longer be evaluating societies as successful based on the GDP, which tends to prioritize higher prices and higher profits. Instead, we should be judging ourselves successful based on abundance being available to everybody. Not an abundance of money, but an abundance of good quality of life. So getting that done won't be easy, but we have to have that discussion, and we need intelligent politics to redistribute, which has been done in the past and needs to be done in the future.
Yeah, excellent, David. Another question here from Subir is asking about China specifically, a little bit of a political question here. With China achieving a strong position in AI, won't it be a bigger threat to global peace and stability?
So there are very worrying developments, I have to say, and we should not be naive about these. And many of my good friends are Chinese. I have a great admiration for what the Chinese companies have accomplished, what Tencent have done, what the Alibaba has done, what Xiaomi has done, and others. It's remarkable. What Huawei has done. Huawei have been successful by applying wonderful principles of quality, and they have not held back. So if I am critical about the potential arms race, an AI arms race between China and America, please do not think that I am being critical of all Chinese work. No, instead, we must find a way to tilt from a competitive, dangerous arms race into more of a spirit of collaboration. And there are some encouraging precedents. And you've already mentioned it, Pramod, when you talked about nuclear treaties. In the past, when I was younger, when I was at university, the big worry in Europe at the time, especially in East Anglia in Cambridge, in East Anglia in the UK, where Cambridge is based, was that America was putting cruise missiles on the ground, and it would likely lead to an all-out nuclear war because somebody would be inclined to try and use them, and bad things would happen. And indeed, Ronald Reagan, when he came to power in 1980, he declared the Soviet Union to be part of an evil empire. And when Mikhail Gorbachev came to power in 1985 or so, he inherited 6 to 8 years of his country regarding the West as evil and the great foe. And both of these two were for a while on this path of arms race. Indeed, Ronald Reagan was inspired to do something called the Strategic Defense Initiative, commonly known as Star Wars, which was designed to have missiles knocked out of the sky. And there was a great deal of worries about what that might lead to. And then a futurist spoke up. I'm simplifying the story a bit, but let me tell it this way. A futurist known as Carl Sagan, who had a marvelous way of communicating. He's well known, of course, for his Cosmos show, but he also was involved in helping to understand the true nature of the threat to the world from nuclear weapons. It's not that the world would heat up. is that the world would cool down via a mechanism known as nuclear winter. And he, with colleagues, did a lot of communication about the possibility, it's not a certainty, but quite a high probability that if a nuclear war were to start, which was the official policy of both Russia, the Soviet Union, and the West at the time, both of them were planning, they could start. What Carl Sagan and others showed, that the dust generated would go into the stratosphere and would cause potentially an extinction or a near extinction of the human race. And people in both the Soviet Union and the hawks in America said, oh, we didn't expect that. And it helped. There were other factors, of course, too. It helped to bring these two leaders, Ronald Reagan and Gorbachev, from being sworn enemies to starting to sit down and smile and be comfortable with each other. And they managed to accelerate various trust-building measures and arms agreements, building on, by the way, what had been done by previous presidents such as Nixon and Brezhnev. So we need the same to happen now. We need intelligent leadership at all levels of society to point out the risks, very real risks of AI running out of control, causing the kinds of things I spoke about in my last few slides, and then encouraging both sides to take part in monitored, audited development of AI safer, so that we will all, throughout the world, get more of the benefits that advanced AI can bring about, including the solutions to climate change, the solutions to inequality, the solutions to aging, the solutions to other diseases of dementia and cancer. All of that is within our grasp, provided we are collectively smart enough to grasp it.
Thank you, David. I'm not seeing any more questions from the audience, but I do have one of my own that I'm going to ask here, which is, and you spoke about this a little bit in terms of AI companies hiring a lot of neuroscientists. So the question is, can AI become as intelligent as humans? And I want to preface this by saying that I feel like humans have been moving the goalpost every so many years. And I'll give you an example. Many years ago, driving a car used to be something only humans can do. And then there was deep learning, computer vision, and now there are self-driving cars. So now we say that, oh yeah, we knew that machines could do that. So I guess my question is, and you also talk about AI having emotions a little bit. So, do you envision a time and age when AI can actually be more intelligent? And we still have to define what that means, but based on what we know today, more intelligent than humans.
Of course, AI is already more intelligent than us humans in many narrow fields. The question can be stated as, will AI be more generally intelligent than humans? And you can give definitions of intelligence, which include things like being able to accomplish goals in complex, in uncertain environments. And the more that the software can work out the right steps to take in uncertain environments, the more generally intelligent it is. I see no reason why AI cannot become more generally intelligent than humans. In fact, I believe it is likely to become very much more generally intelligent than humans. We can talk about going to AGI and then to ASI, artificial superintelligence. Now, what I've been talking about so far in this presentation isn't saying we will go all the way to AGI. I've just said that there are many steps up from today's AI which will deliver a lot more power, a lot more intelligence, and therefore bring more risks and more opportunities. But I do think in due course we will reach artificial general intelligence. And I listen every time people say they don't believe in artificial general intelligence. I try to find out their reasons, and I haven't found a single good reason despite listening for more than 20 years. There are various fallacies in people's minds. They look at their own children often. It's often an emotional thing. Sometimes computer science professors have young children and they just fall in love with their children, as parents do or as grandparents do. And they say, wow, such a clever thing my young child did. There's no way AI could ever do that. And what they mean, they can't personally conceive yet of a way in which AI can do that. But that argument for ignorance, from ignorance, is a very bad argument. There have been many cases in history when people, great eminent physicists, scientists, swore that something could not happen, and then in remarkably short time, people found a way. So you have to believe, if you really think that there's no way to get to AGI, you have to imagine there's some kind of mystical or spiritual or ghost in the machine, which is placed there by some divine source, which cannot also be placed into silicon. And I see no reason to believe any such thing. So I think it's very likely we will in due course have AGI. I think there's at least a 50% chance we will have it by mid-century. And I think there's probably between 10% and 15% chance we'll have it by 2030. It all depends on what will be unlocked by some of the breakthroughs that I've spoken about. It might be that one of them is enough to take us all the way to AGI. Probably not. We'll probably need 2 or 3 or 5 or even 10 such breakthroughs. But the breakthroughs are likely to come quicker, because the more we have AI helping us, the more that AI will be able to come up with new suggestions and innovations. This is the fast takeoff scenario. So I'm still waiting to hear a good argument why AGI is not possible. And if somebody has got it, then I'll pay them attention.
Yeah, maybe we should invite you back on a presentation on AGI, artificial general intelligence, at some point. But for now, thank you very much, David. I know it's late in the evening for you there, so thank you very much for joining us. I personally enjoyed listening to your insights, and I'm sure our audience did. Once again, this presentation has been recorded, and it will be published on our Meetup page as well as on social media.